device. So let's first go into the root cause. The existing fruit wrapping tools are generic and there's no integrated measuring system. Also, it lacks soft touch mechanism. This leads to low productivity. For example, it took 90,000 seconds for 3 holders to wrap 100 trees. And also, it reduces fruit quality. Our target users are large-scale Harumate mango farmers in British Indonesia, and by large-scale we mean farmers that has 200 plus trees. Our job type is directly linked to our user needs. First is effective wrapping. We have to ensure that our telescopic pull weight is less than 3 kg to maintain portability. Next is accurate sizing system. We have to accurately measure the fruit diameter, which is 5 cm, before wrapping. Lastly is effective fruit protection, is to prevent bruising by 85%. The current solution does not meet all 3 criteria. Our Harumate solution meets every single one. So first, effective wrapping. It is automated wrapping and ground operation, which promotes safer operation. Next is accurate sizing system. Harumate has ultrasonic sizing to measure the size, which provides accurate sizing measurement. Lastly, is effective fruit protection. We have soft touch mechanism, which protects excess pressure. Harumate operates on 4 key principles. First is reaching and wrapping mechanism. We have telescopic pull, which can be extended to desirable height. Next is mango size detection. We have ultrasonic sensor to measure the sizing of the fruit. We have safety mechanism. There are silicone pads at the clamp to prevent excess pressure. And lastly, user feedback and control system. We use Arduino microcontrollers such as PSP32 to ensure our process occurs in correct sequences. And we have LCD to display the size measurement. Last, we have push button to allow user to confirm readiness. For design specification, we also link it to our user need. First is effective wrapping, lightweight telescopic pull. Our engineering target, telescopic pull weight must be less than 3 kg. Next is accurate sizing system to measure the mango diameter. Engineering target, we want the sizing accuracy to be more than 95%. Lastly, effective fruit protection, soft wrapping mechanism. Our engineering target is to reduce the damage for about 85%.
Next, I will present the design analysis and the flashcards for our project. First, for effective wrapping, we use telescopic pull. For design analysis, we calculate the outer diameter and inner diameter of the telescopic pull, where the pull weight is less equal 3 kg and the pull length is adjustable up to 4 meters. For the outer diameter, we got 18.81 mm and the inner diameter 17.3 mm. But our prototype only able to get the telescopic pull. The outer diameter is 22.3 mm and inner diameter 21 mm, and the height is only adjustable up to 2 meters. And the new mass should be less than 2.1 kg. This is our test card. To verify that, we will measure the diameter with the caliper and weight the assemble fold. Our concept works if the diameters match the specs and the weight is less equal 3 kg. Second, for accurate sizing system, we use ultrasonic sensor. For design analysis, we calculate the position of the ultrasonic sensor to measure the mango diameters in the ratio of 5 cm with 95% accuracy. Precision we get is 0.3 cm. This is the test card. To verify that, we will view the ultrasonic sensors reading on the LCD display, comparing them to the ideal size of a mango, which is 5 cm in diameter. Our concept works if the size accuracy is more than 95%, and the error margin is plus minus 0.3 cm compared to the ideal size mango. The last one, for effective fruit protection, use silicone pads on the clamp ends. For design analysis, we want to find the thickness of the silicone pads, measure the contact pressure less than 10 kPa, thus supporting the 85% damage reduction target considering the deflection of the pads is 0.1 mm and the thickness we get is 12.4 mm. This is our test card. Feature to test is contact pressure at clamp ends. To test that, We will attach the silicon pads, measure the contact force with a force gauge, and calculate the resulting pressure. Our concept work is damage reduction efficiency matched to 85% and contact pressure less than 10 kilopascal.
Next, we move to the social, environmental, and economic impact, where the economic value is related to the effective food protection and accurate service system, which contributes to the higher product quality. For effective food protection, it it will reduce the waste from the it will reduce the it will reduce the waste from the mango from losing, and also accurate sizing system. It will wrap the mango at an ideal size around 5 centimeters, which if we wrap the mango more than the size of ideal size, the taste of the mangoes will be affected. Next, we move to the societal well-being, which related to the effective wrapping. Enhance farmer safety by reducing risk of accidents and needs of ladder. Lastly, for the net zero carbon concept, it related to the solar power operation, which aim to integrate solar power charging system, which the farmer can practice sustainable farming environment. Next, for the public safety and regulatory compliance, for the telescopic poles enables ground level operation which eliminate height hazard and related to the effective wrapping, which can reduce the risk of accidents and also the risk of ladder. Then for the damage prevention, the silicon sided clamp prevents fruit from bruising, and it's related to the effective fruit protection, which ensure good quality of mangoes and also reduce the waste. Next, for the our system also implement video feedback, which through LCD display, the farmers can also wrap efficiently as our system monitor the feedback. Then for the professional responsibility, our system guarantee ethical accountability in its use. Lastly, for the stakeholder analysis and complex landscape, we engage with diverse stakeholders, including farmers, industrial experts, and agencies. Next, for completing requirements, we address our conflict by design adjustment and testing, which bridges the gap between wrapping efficiency and safety. For closing the gap in standards, we combine traditional manual methods and modern automated techniques. Lastly, for the ethical and global responsibility, we design to fit local mission farm to be applied to diverse regions. This is our prototyping and validation process.
Is it functioning now? Is it functioning? Can I see a demo?
Like that, it's not functioning because we need to connect with the power source and
Do you have any intention to make it functional when you present here?
yes,
Because we have power extension over there.
We had, but there's a problem with the assembling as well at the wrapping part. So
Okay. What's the problem?
The mechanism is working, but
The wire.
the wire.
The wire is like if something is rotating and you.
Yeah.
Okay. So how are you going? Is it solvable?
Yes, it is solvable. We plan to put more like container and extendable behind it so that the wire doesn't.
Is it just like you just completed like very near to this and you just somehow found the problem at the last minute?
Yes.
Okay, alright.
During assembly.
So the validation that you showed, what is it then?
It's part by part, right?
Yes.
That's why. Answer for.
Maybe that like separately it works functioning.
Yes, everything is functioning except when assembling. I
When
think
you
there's
assemble this, everything can like
yes, because the wires are tangled together.
so you really have the exact time starting from it starts to wrap the whole mango, so you don't have that estimate time.
And another thing is, you need to have power, right? Power, it has to be connected to the. Then, how people are going to use your product? Like, is it they have to bring this long extension from their house? What?
No, actually, when we use the IoT system, we can use the like something like the power bank.
Use power bank.
Yes,
But your design is not.
our problem here is now the wire is tangled and then
No, you design it in such a way that it should be connected to the power source, or
If you use it in the field, the mango tree, whatever, how are you going to get the power there?
We can use battery. Actually, we plan to use solar battery, but we
so your design right now is
Okay,
AC,
where,
right?
Where can you design that you design
Because power source is AC,
the power needed?
battery is DC.
we need the calculation for the battery.
Aduk.
We actually plan to use the rechargeable battery, and this is the calculation that we make for that battery.
Okay, so did you buy the battery?
we bought, but we have the charging port, but the battery exploded.
Oh, you bought the battery but it exploded.
No, we actually borrowed from the office.
Then the battery exploded.
Yeah, then the battery exploded before we can use it. So we're ordering by this.
This one, the budget to operate what? You have the ESP, what is that? Microcontroller or what?
Microcontroller.
Okay, and what other parts that they need power?
The mini servo and motor for the wrapping process, liquid LCD for display, ultrasonic sensor to measure the size, and that's all.
So you use all this to get your battery, right?
Yeah.
Okay. But so this one, how, like the motor, what is the design for the motor? So this one you didn't show the design analysis. This is like the couple appendix or what?
This is just our
Backup slide.
Backup,
Because
okay.
before this we put in the design analysis and then Prof commented that our design analysis not in line with our that's right.
All right. So let me go back similar to the other group. I think, can you go to your design spec? Okay. I don't know this one. How the effect of wrapping, and then it is related to weight. My understanding is that to be wrapping, like effect like this is my mango, and I have my system, then it should be able to wrap it whatever. You know. That's effective wrapping for me. But then you say telescopic pole weight 3 kg for the wrapping? I don't get it. I don't get the thing.
Because in the wrapping process itself, manual farmers that use manually have to carry ladder everywhere. So we're eliminating the ladder usage.
But then that's not the effective wrapping. Let me understand again the wrapping. We have the mango, and you're gonna cover it, right? Or no? With a bag or something. So where is that in your design here? In your design spec? That's you're doing something else, that's you removing the ladder by whatever, this telescope thing. I don't know. Maybe you can have another design user needs for that, you know. You think about it. It's not the wrapping itself. The wrapper for me, the operation of wrapping is this, fruit, and I'm gonna cover it. Yes? Agree or no? You cannot agree, just convince me, that's all. Alright? So that's why I don't see the wrapping, which is a big part also of your design, of your product or whatever target, that you have to wrap. Sizen, okay, you get the sizen, and you get this for, so this one, the effective fruit protection, how this is, you need the damage to be less or whatever, right? And so we can do question the mango in this case, to reduce the damage. So here is not really the wrapping itself, again, the mechanism. Just here, you're going to use something, then when you wrap, you don't damage the fruit, right? Okay. So I see the wrapping is missing here. But let's see now, I mean, for your systems, here, what is the one to the, for example, this one, the size, right? How do you detect the size?
We use the ultrasound sensor.
Uh-huh.
Then we will extend the pole to the mango and
What is the sensor?
this one.
Okay, there it will, then there will the size. They will give you the size.
Yes.
And then how do you know, where do you know the size?
We have the LCD right here. We will use pole.
And then it will give you the size.
Yes.
And what dimension or whatever the size.
Yes.
The liter of the money.
Yes.
Okay? And then after that you decide to go for the wrapping.
Yes. If the size meet the 5 cm,
Yeah?
then we will wrap. We will go to the wrapping part.
How?
And
So now you did it. No, you did this. Let's give it the sequence. So now you get the size.
yes.
After that, you bring it down, up, whatever it is.
No, we don't have to bring it down, just push it up so that the mango is right now in the second tier.
And the second one, in the wrapper. Okay? You go there, alright? And but you are like, how high is it?
4 meters.
4 meters. So how you manage to get the right things from the bottom? Do you have any measurement?
No, because we have the telescopic pole, so when we see the mango is a bit lower, we can adjust it.
I understand, but then you might go for the damage.
That's why we have some content. Yes.
Huh?
There's going to be silicon pad around it, so if it hits other mangoes, it will bruise.
But your mango there that it comes, okay, so now you do the wrapper, okay? So it go,
So the
yeah, you got the dimension back, you go up, right?
yes.
Okay, bring it up, let's say. Then you have the bag.
And this bag will be open and we will fold it.
See, like now it's still telling me as if you are at the beginning of IDP. It will open, it will do, now it should open, it should do now. Right, so it will work, it didn't try it, right?
Mechanically, how that wrap will be attached to that?
Actually, this end here
Yeah.
will be attached to this.
Okay, can it be attached now? Because you don't what you don't have right now is just power supply, right? Meaning that mechanically it can be.
Nice, but we should do that.
Okay.
Okay, so this is the wrapper.
Okay.
We insert the wrapper paper at the clamp, and then the
Clamp it. Okay, alright. Good. So it's like that. Okay.
and here we have the wire, and then we push it here.
So all this will be done by your system?
No, this is our project is partially automated. So
No, but it is there for
Yeah.
This is the first step. We have to put the wrapper first.
Right now it's at the bottom. You have to
Yeah.
assemble it first. Okay.
And then only you extend the pole and measure the size.
Okay. Now we are in the stage of pushing it, right?
yes.
Okay. Now
Now
continue.
this one clamp, this one end will be inserted in this.
No, so that one, when it is completed, how is it going to happen?
This is
This is will do it. You press something, it will do.
This is set on the ground.
We put
See on the
the
ground.
and also in between.
I understand, but how is that later there? How are you going to hold on?
We have push button so that.
Okay. You push the button. You push the button.
Then you are there, then you press, then it will clamp.
Yes.
So it will stay there, then you can do things, it will remain.
Yes.
Okay. We do it on the ground. It's not for me to Okay, then, after that, okay, the damage then, how you measure the damage?
We plan to use
Force gauge. We plan to use the force gauge, and then from the force that from
We
the contact.
plan when you repeat the IDP next time.
Not really, because we didn't do the realization of right now.
Because this one you should, like I said, now should be everything done. But if you have something, hopefully by next week you can finish everything. So, and then the target here, the 95%, how you measure that one?
Okay, so from the 95% accuracy, just now in design analysis, we get the precision for the diameter 0.3 centimeter. So our ultrasonic sensor we measure 5 centimeter and plus minus 0.3 centimeter. So
It will display.
yes.
Okay. So the wrapping, you don't do, the only thing the wrapping is, what is that mechanism just to close the bag on the fruit or what?
No. Actually, for wrapping, if local farmers are very specific with their wrapping. So actually, the wrapping is you have to fold the coil until the end.
So this is you design your own graphic.
No, this is the original wrapping.
The one that they use.
Yes, it's a carbon replica, so they don't want to change the.
Yeah, good.
Okay.
That's good.
So this is if you want to know
Yeah,
the
because now they do it manually, right? They wrap. Alright, but now I want how that manually is done by your machine.
okay, this is the wrapper and this is the 5 centimeter handle.
Yes.
So if the manual operation is first
Put it in.
farmer will
Okay.
and they will
Don't close.
fold the paper.
Oh, they do it like that. Huh? Video.
And then this wire they will wrap around and it will circulate.
So all this now that you did with your hand and your machine will do it?
Yes.
I have to see it. To believe it, I have to see it because a lot of work there.
That's quite a challenge.
You know. But if it does, very good.
Yeah.
Yeah, if it does, it will be very good. So I expect you don't sleep for the next week. You don't maybe eat minimum, that's the remaining, that's to finish this one. And actually this one, the root was also not very good. Yeah? But that's okay. Even if you don't do it, do it for now, it's okay, as long as the mechanism works. So focus on the mechanism that all these three things they work. Later, if you have some time, then you can cover those wires and stuff to make it nice. Okay? But if the mechanism works, actually, that's secondary for me. And later you can do it if you want. Of course, it usually gets a good impression of it. Depends on the level. Alright. So, I mean, it's good and not good, right? So good that I can see that you understand what you're doing and you did proper things, but that's still missing a few things. Design analysis also, I don't want to go into much detail, but just I want to see just one case maybe of design analysis. Pick your best one and show me that you did it properly. You start from the engineering target and you find specs on one of the components. Just show me one. Pick. I'll let you pick. Your best, you think, whatever you think your best design analysis. Don't pick the 3 kg because for me the 3 kg is not fitted to the rocket. Okay, for example, this one is the size? Because the size or the damage? The size, the simpler one, I know, you pick the simpler one. Okay, so you have the size. What is the engineer's target here?
The 95% accuracy.
Which is the precision?
From 95% accuracy, we got 5% error. So, from that one, we is in the percentage errors.
So, okay, where? The precision here, what is the precision? That's what we need to calculate.
Means that.
Right?
Yes.
The percentage error is the 5%.
Yes.
So you put the, from your engineering target, you put it there. By D over 100, then you find the precision. And then, is that precision, that's how you get to your ultrasonic sensor?
Yes.
The stack of the, can you see some of the stack of the ultrasonic sensor? One of them is precision.
No. The precision is not the spec for the ultrasonic sensor.
Oh.
It's just for the measuring process.
Yes, but how did you choose your ultrasonic sensor based on this? That's why I think I asked you this before also. You need to have some spec for the ultrasonic sensor. I mean, you cannot just pick an ultrasonic sensor, different maybe whatever accuracy. I don't know what is the spec of, like the motor you need the power and the torque and stuff. Also, precision, the ultrasonic sensor you need some specs, right? So you need to link some of the specs to the engineering target, and then you say, oh, I'm picking ultrasonic sensor X100, for example, because it meets my requirement. Okay? Alright? Yeah. Oh.
Actually, we don't do that, but we search about the specification of this ultrasonic sensor, and we got the position of 0.3 to 0.25.
What is that?
The precision.
The precision of the sensor.
Yes.
So one of the specs of the sensor is precision.
Yes.
Okay, that's what I want to see. If it is, then okay. Then you get like this or alright. That's why I said you have to know. For every component, you have to know what is its spec first. Like they need the vibration, the damper, the gel, they need the K, for example. Right? Now I have to do this to find what is the K. Here's the same precision, then I did my engineering target, and I get the precision, and then I say, oh, based on this precision, I can pick this sensor. So all your design analysis should be the same. About every component. Alright, good. Thank you.